Hello. So with this screen recording, I'll be demonstrating how to perform a paired samples t-test on two variables that I well, on my two variables, my control and experimental conditions data that I've collected from my participants during my dissertation. And like always, I have to open up my JupYiter notebook that I use for my Miniconda Python um, software, or what it's called. And over here I open up my notebook that I'll be working on, and with every um, new notebook I open, the first thing I always do is I go to my clipboard where you see I've pinned the libraries that I want to use, where I have my pandas library, which is the pandas is just for the regular data manipulation that you'll see me doing, as the numpy is for my numerical computing with the arrays and matrices. It's for like the mathematical operations. Um, and then the other ones will not be used for this t-test. Um, However, they're just nice to have in case that I want to do more with the t-test. So let me go ahead and import those. Now, next thing that needs to be done is importing, well, reading actually the Excel document that has the data that I want to use. So for that, in this case, to make my life easier, I've also got a clipboard for that, and I'll call this new variable, well, the arrays variable um, dissertation, where we'll have the numpy library read the Excel file located um, in this computing path, which is this guy. Let me just go copy as path and bring that right here. As you'll notice, I put an R there already, and that is just so that this whole string, this whole path, is now recognized as a raw path, a raw string. Whereas if you had the C by itself, starting the whole thing, in fact, one thing that happens is these backslashes get recognized as something known as escape codes, which generally can just cause sometimes issues. It happened to me, and I did a bit of investigation, found the R, putting it there is just a nice way of moving around from those issues. So we have that there, and now we can visualize our array that is stored within this variable, like so. And well, we can notice that those unnamed and NAM, so no um, numbers there, we want to actually get rid of that so that we don't have to really look at it. We can just format everything so it looks a lot nicer. And what I'm doing right now is I'm telling the um, uh, this notebook using this drop NA function to basically drop these different columns so that it only includes the columns that have something written in them, which is this all. There we go. Now, next things first is what I like to do is I actually have I have another clipboard that I like to use, this guy, and because I've been working with all this a lot and I've been naming everything dissertation, so it makes life easier. This just will tell me all my columns in a kind of printed format, so it makes it easier when I want to copy and paste them. I just highlight and copy. Um, but yeah, that's just to make my life easier. Now to actually perform the t-test, what I'm gonna do is, as this is this is a simple kind of test, no matter what program application you use. In this case, that's still the same. So I'm going to create a new variable that contains a data frame that only includes these peak power columns of data. That way, everything I do from now on will just be done on a data frame with just those variables. So, like I said, I can just copy this guy over, like so, and I will copy his friend, like so, making sure that I have these, not commas, but the commas in the air, because that is what defines these. Because without them, if you'll notice, that loses the red highlight. And we don't want that to happen, because that means that it is not defined. And actually, one thing that's quite nice to do is put this on a second line so that we can visualize our new data frame. Perfect. That's exactly what we want. Now, you can, with these libraries, you can perform a regular single sample t-test or individual t-test. However, since I want to do a paired t-test, I'm going to have to import a different library, which is the Skippy stats library, which can be imported like this. In fact, I have a clipboard for this. Actually, I do not want to import stats. I want to import its t-test function that's within it. And actually, because that's going to be a pain to write later on, I'm going to rename that. So this is just saying from the Skippy library, I would like to import this function, this specific kind of test it can do, and I'd like to rename it as t-test. So I do not write it as this anymore, I write it as just this. It makes my life easier. And actually, within the same box, I can just do everything else. Statistics, yeah. And also, that gives us a t-value, but we'd also like our p-value. So that will show us the significance of the interaction, or of the differences, I mean. And now that is our function that will be used. And so, like that function used on this variable for this column. I have to, because within this, it's basically saying it wants a A/B like you find it in Excel, and here is my A, and then in this next one here is gonna be my B, so the two columns of data that it will be doing the t-test on. And that looks good. Or no, I think I forgot to close the brackets. Ooh. Yeah, there we go. So, and I forgot to actually print the results. Always forget to do that. And I'm just saying, let's print that F and P statistic. Actually, I have just realized that I've called statistics, which means here I'll have to call it statistics as well. Um, it's equal to dot for f. And now for the p-value. Um, or actually, no, I'll just keep it as statistic. This is where that matters. Well, yeah, just the same as the other one. And to close everything off. Oh no, I need to add in one of these. And now I can close it off. And so here we have our t-value and p-value, which looking at them here, our t-statistic for one is quite large, which would mean that there's a bigger difference between our experimental and control condition relative to the variations in the data. So I'm more likely to accept the alternative hypothesis that there is um, a difference between the two. And we're looking at p-value. This is less than 0.05. Therefore, we're likely to accept that there is a statistically significant difference between the experimental and control condition. Experimental and control condition. And so now to actually visualize the difference, I will be performing a I'll make a bar chart in order to show this difference. And actually, before that, I've run these tests with SPSS as well, and got different values. With like my p-value through SPSS came out as 0.002, whereas my t-statistic was 4.876 or somewhere around there. But reviewing the data that I had beforehand, I noticed that my SPSS data was to 5 significant figures, whilst this data set that I'm working with, the peak power and for experimental and control conditions, you can notice that they're at 2 decimal places, which is reason enough as to why they've got negligible differences but show the same um, thing. Actually, another notice that can be made of the t-statistic is it's positive, and therefore this first group that was measured, the um, experimental condition, is this positive. Being positive just demonstrates that the experimental condition has a larger mean um, than the control condition, which we will see with this bar chart. So first thing with this bar chart, I would need to find the means of the two variables. So to do that, I'm going to create a new variable where it is taking the dissertation tests columns of data, which is this guy. That's perfect. And it's just using the function, the mean function, from the, I believe it's NumPy. Oh no, from I think it's Pandas library. using the mean function to for that. And likewise, I will bring over and find the mean for this column of data. Yeah, and use the mean function as well. And alongside that, I will be doing the standard deviation, which with writing it is very similar, but we'll just be changing this around so that it is standard deviation instead of the standard deviation function instead of the mean function. And now this is calculating our means and standard deviation for the columns of data. Oh, and one thing that I have not done is, like with everything else, I need to print the result. And so to do that, I just specify here I specify that I want to print, and now with this in purple, I'm just saying what I would like the kind of heading or the titling for it to use what I want it as. So for the first one is we'll do the experimental. I'll use the control mean first. Specify that is here. And actually, this is where it can get very complicating to fix, as now I'm deciding the order that I would like the data to be shown up on later on actually. So I've specified that the mean value for the control condition will be specified when the number 1 is present, which we'll see later on. And likewise for my standard deviation, I'd like it to be recognized as standard deviation. And I'd use the stds data frame, stds variable and specified that for this, as this is in the same line of code, it's just nicer to, as we'll specify, the same order, which is 1 to F. And I can close off my parameter. And now it's doing the exact same, but for the experimental condition. So I just change this. Experimental mean, and well, now I want to change this order around so that it's 0, because I can't have them be the same order, otherwise that does create issues. And this should print out like so, and so we can see that our control mean, so this guy here, peak power W.1, has a mean of 558.48 watts, standard deviation of 131.25 watts, and likewise our experimental mean has a mean and standard deviation of this. And this is nice to have, but if we want to now turn it into a bar chart, looking that I have two variables, scientific variables that were measured, I know that I'm going to have to put labels for them if I do the bar chart, as they will come out with two bars with each for their own mean and standard deviation. So here I'm just going to specify the labels that are going to be used will be called the control and the experimental. We'll call it. And now specify that my mean will be so I'll be using this data frame, this variable to do my means, which I spelled wrong here, and it will be using the that order that I talked about before. If I was to be putting this as 0, then that would mean that the experimental conditions data, or mean and standard deviation, will be the first bar put. However, I do not like that, so I will be putting the control first and then the experimental, and this is how you do that. Likewise, I'll have to do this to my standard deviation. To keep them in order with each other. So this by itself is just the ordering and the labels of the bars. The actual creation of the bar chart is I will take the figure function, which is used by the matplot library, the matplot library.pyplot library, which I've abbreviated to PLT. And so that's what I'm doing here. I'm using the matplot library to create the figure, where I have the figure size at from trial and error. I have found that 6 and 5 are reliable for these bar charts, and likewise I will now have to create the actual bar itself, where I'm including all the data that I wanted to include. So the labels, so I'm specifying the labels, and now the means, the what it will be using for the standard deviation. So this is saying that it would be using the standard deviations within this data frame, this variable's data frame. So I put that here. Do some more changes to the size. And actually, a very cool thing that I found, I mentioned it with another one, is changing the labels. So plt dot y label specifically, as I do not want an x label, as that would be my my general bar labels. So for my y label, I would like to name it, let's call it just peak power, and specify the units. And then likewise with other tables or figures that figures that I've made, I have a title, and I will call this one the mean peak power for control and experimental conditions. Yeah, and now I'm just gonna make sure that everything's got a nice layout. This was what I was taught from some investigation to do, as it just flushes everything out quite nicely. And this next one is actually just to show the using the show function to specify, to display things. Was never closed. PLT label. Ah, yes. Very nice with these errors. They actually tell you, usually if it's a syntax error, it can be quite easy to see what was the error. And well, here is the bar chart. So here we can see our control condition and experimental condition, the mean and standard deviation values for both of them. However, checking with the title now that it's a bit bigger, I can see that I spelled experimental wrong. And this is when it's just very easy to go in and fix things. Just change those around, and there we go. Another thing that you might have noticed is how it's automatically given the bars a dark blue hue for both of them, without being able to not really distinguishing which one is which. Whereas in Excel, if you had those two sets of data, they would give you two different colors. Now, I learned a very cool trick in order to change the colors. It's pretty intuitive and easy to do. And it's where I just specify that for our first bar, I would like this to be, let's say, sky blue. This is one that I've tried before, and I just think it looks nice. And the other one I'll put salmon, so we can really see the differences between the two. And this is because I have forgotten to actually put these all into its own thing. But there we go. Now we've got our own bar chart. So looking at the bar chart, we can see that it follows our control and experimental variables. But then with it, we can also see that the t statistic, this high t statistic, positive t statistics showing that the experimental in this case, as it was the experimental against the control, this is just saying that the experimental was definitely a mean higher power output than the control, which we can see here. Likewise, we can see that this was showing that it was a significant difference between the two, and this is now visually displayed with this bar chart. Perfect. Another thing that I can actually do is you'll notice that unlike Excel, if I don't specify in Python, if I don't specify to have grid lines, they won't come out. So actually, if I wanted to add grid lines, I would just go at the end here, and I'll add another thing for my from that library. I'd add its grid function, specify that for the grids will be against the y-axis. That's all this is this first part is saying. And I'll specify the kind of font or the character used for the line. So this is where you can choose if you want a dotted line or a straight line. So for this, this should be just a regular straight line. Okay, so let's come out in the wrong place. It's because actually it prefers it when I have it um, behind the actual showing the whole creation of the bar chart. So it has to be embedded into this whole cell. So this should fix it. Yeah, perfect. Now, if we wanted to change this line size, which sometimes we'd like to do that, I would just specify a specific size, which I'll put 0.6. That will change it around. And there we have the grid lines to it. However, I don't think the grid lines do this one justice as it goes across the bars. Not a great fan of that. And I need to do a bit more investigation as to how to do that. But yeah, there's the bar chart. Perfect.